Get twisted Sundays, look. I ain't gonna wait till the beat drop. I'ma get it while it's warm and start to form this heat rock. I spit classic complex progressions, my whole flow is bebop. I bless demographics with lessons cause my bars are sheetrock. That's hard. These scars gon' get me to the treetop. I'm different now, but I used to keep my eye on tail like peacocks. Changed my perspective, got selective on what line I eavesdropped. Switched to the main one, then refrained from all the dames that pee-popped. They were thotties. Used to smash them as hobbies, but I'm godly, no problem. I bring Yeshua to the hood. Mama need a met fat, she said, yes, he blessed and you're good. My cousin, whole life a mess, cause he stay obsessed with the jug. I try to confess I'm blessed even when my life dark is shugs. Last name, that's night, don't get it? You probably snoozing, I make it clearest, my dearest. Whenever the spirit moving, I'm trying to spark up reunion. Bring back all the real rappers. Donald Trump when the president, preachers say that the rapture is coming. So we on our knees praying to get acceptance. If we made it in his image, then why can't I see reflections of love? They project us as thugs. Hell, my partners need hugs. We straight out of the mud. I told my pops I'm the plug for purpose, passion, talent, skills, and everything that's above. Hell, the poverty line. If I ain't the best, then they probably lying. The flow touch those boys probably divine. And the whole risk go, but I hardly got time for Facebook posted. I partly designed to play fake hope and I'm partially blind. And I told Miss Roger she ought to be mine. And we start dating. Practiced abstinence to dark Satan. I'm cool with waiting, but swear it took revelations in Genesis. Matter of fact, the whole biblical compilation, the defense of Gary Payton and hella spiritual patrons to help me. Cause I was trying to GTD like Tommy on season 2, probably episode 16 of Mud. Man, R.I.P. Tommy Ford, but please check that episode just to see how much more I put in there. Every score I pin, I scrub the floor with men who say they rap, but really industry whores within. I'm done, bring the chorus back in. But ain't no chorus though. Yeah, but ain't no chorus though.
God, fucking love Toby. Well. Look who decided to show back up. Alright, so, back from vacation. Yay. Get some back alive on the grind. Back to this goddamn dumb fuck. Okay. So, I'm gonna actually for real try to get through this video. Yay.
Well, what this means.
So to recap, we have gone through seed oils and soy, and that's about it. Which is why vegetables are bad and you should only eat meat, I guess. Hopefully we can get through the rest of this. Tomorrow we can start actually reading stuff. Might have to organize this offline. Because this is ludicrous. Hello, Mr. Man. Did you miss me? Did you miss me? Okay. Well, hopefully we're somewhere fucking close to where we were. Anyway, gone through seed oils, soy, and now we're getting into why meat is good. So, yay. Let's fucking...
Means is animal proteins typically contain all essential amino acids in quantities that are optimal for human consumptions.
Let's rewind this a little bit.
So it has a complete amino acid profile. And what this means is animal proteins typically contain all essential amino acids.
What proteins?
So then, again, the positives to eating meat. So it has a complete amino acid profile. And what this means is animal proteins typically contain all essential amino acids in quantities that are optimal for human consumption.
Okay. Animal proteins contain all amino acids in, did he say ratio?
Proteins typically contain all essential amino acids in quantities that are
All essential amino acids in quantities that are optimal. Okay, we need to fucking hang on, this goddamn how loud is, okay, Jesus fucking Christ. Hang on. Fucking compressor. Or not compressor, expander. Okay, hopefully that's better. That are optimal for human consumption. That's still fucking loud as shit, isn't it? This might be true. I don't know. There's a lot of tryptophans and such. Not tryptophans. I don't know. That's definitely one to look into.
are optimal for human consumptions. So if we were to compare this to like, let's say soy or any of these other like plant-based proteins, they don't have the amino acids in them as well. So
Soy doesn't have essential amino acids.
they might have the protein, but they don't have the actual amino acids level. And
They might have the protein, but they don't have the amino acids level. I don't know what that means.
the whole kind of like what we'll get into later is just like the whole kind of comparison that you need to eat twice the amount of plant protein that you're eating as animal protein to get the enough protein that you need, because it just does not absorb as well.
Need 2x the amount of soy protein to get the same amount as animal protein. That's probably true. Animals or rather, yeah, animal products or meat rather, does tend to have very bioavailable protein, which is, yeah, it's probably true.
When we're talking about essential amino acids, what we're talking about here, these are the amino acids that the human body cannot synthesize in significant quantities by itself, and it therefore must be obtained through diet. Some of these are histidine, which is important.
Essential amino acids, histidine.
For growth and repair of tissues. You have isolene, which is important for your muscle metabolism.
Isolene. I think he means isoleucine.
Immune system, and your energy regulation. Leucine, which is also a BCAA, which plays plays a key role in protein synthesis, muscle repair, and growth. Growth hormone production. Lysine, which is not necessary for hormonal activity, enzyme production. Methionine, which contains sulfur, which is necessary for
Lysine. Did you say methionine? Methionine.
production of very hormone production. Lysine, which is not necessary for hormonal activity, enzyme production. Methionine, which contains sulfur, which is necessary for the production of various proteins in the hair, skin, and nails. And again, this is what we're saying. It's like these soy boys, like they start to lose their hair early and all this kind of shit.
Soy boys lose their hair. because methionine is essential for hair and nail growth.
Because they're not getting these amino acids from their soy. Then you have phyalanine, which is a precursor to
Phyalanine? The fuck is phyalanine? Oh, phenylalanine. Phenylalanine. Okay, you can't read.
neurotransmitters. So again, this is for brain shit like that, dopamine production, all these kind of like chemicals that go in your brain. Theanine, which supports cardiovascular, liver, central nerve.
Okay. Theanine. Threonine?
Nervous system and immune system functions. Thyropan, which is precursor for serotonin, neurotransmitter.
Thyropan. Do they have different amino acids in fucking in Ireland? So
transmitter that helps regulate mood, sleep, and appetite. And you have valine, which is another BCAA, which is important for muscle growth and regeneration and provides energy for the muscle tissues. You get all those naturally from your meat, whereas you're only going to get some, if not any, from if you're trying to get it from plants as well. So not only do you have to eat twice the amount of protein from the plants, you have to eat particular plants to get these amino acids with it.
amino acids. Let's see. These are only found in specific plants.
As well, which further just completely complicates the diet. Whereas, like as a carnivore like myself, why I'm looking so fine, fresh, is because all I do is I eat the meat and I don't have to worry about these amino acids because I know I'm getting them all. Then we're
Which complicates the diet. God, why would you ever want to eat more than one thing? That'd be fucking crazy. But you have not autism?
going to talk about bioavailability. So the proteins of animal sources are generally more bioavailable, meaning the body can digest and absorb them way more efficient than plant proteins. There's research and studies out there that are suggesting you need to eat twice the amount of plant protein than you do.
These are 2x bioavailable as in meat compared to plants. Which is, yeah, that's probably true.
Do animal protein. So, and just for people as well, you want to know how much protein you should be eating. You basically need to eat 1 gram per pound of body weight. So if you weigh 140 pounds, you need to eat 140 grams of animal protein. If that is, we're talking about plant protein here, you need to eat 280 grams of plant protein. And then if you do the math on that, that's almost, what is it, like 2.5 kilos of plants that you need to eat. And that's just to get your protein.
Wait, what? Okay, so meat isn't purely protein. What? Beef nutritional facts. So what? This is 85 grams. So, okay. To get 1 gram per pound protein, body weight. Body weight. We'll say 440 pounds. You'd have to eat 140 grams of meat, protein, or 240 grams plant protein. So if we're looking at okay, there's 22 grams of protein per 85 grams. So what? We multiply it. Oh, duh, just 7. Okay, so 85 times 7. So that would be 600 grams of meat a day. Hi, yes. Fucking cats, bro. Let's see. Let's do 22 divided by 85. Let's see. Meat is. What the fuck is the other? What, like 85 grams? That's what, 35? What is the other 50 grams? That's annoying. I don't know what. Whatever. 25%. Okay, whatever. Listen, come back to that one.
Need your fat, all that kind of stuff, and like we were saying, the amino acids on that as well. We have nutrient density. It's such a nutrient. Like if you were to actually put red meat on the scale of these superfoods, red meat would be a superfood.
Nutrient density. If you were to put red meat on the scale of superfoods, red meat would be a superfood. I don't know what that means. That is kind of reflexively true. Like if you were to rank meat on the scale of superfoods, you'd be calling it a superfood. So I don't know. It's a kind of vacuous statement.
Animal proteins come packaged with other essential nutrients like iron, vitamin V, zinc, and high quality fats, and omega-3 acids as well.
Has iron, zinc, vitamin B, omega-3s, high quality fats.
You're getting the omega-3, all this kind of shit, and especially fish. Fatty salmon is really good for omega-3. The only deficit to that is because of the amount of poison that's gone on, basically poison that's gone on in our oceans at the moment. There's a lot of like mercury and all that kind of stuff that goes to the fish as well. So that's why red meat is basically king. Satiety as well. So if you eat a lot of protein, a lot of fat, and you don't have any carbs in a meal, you might think, oh, but my brain, you won't. You won't have any of this crash that you have. You won't have any of this bloating that you typically get. So
Oh, God, why are we doing this?
if you like, that's why red meat is basically king. Satiety as well. So if you eat a lot of protein, a lot of fat, and you don't have any carbs in a meal, you might think, oh, but my brain, you won't. You won't have any of this crash that you have. You won't have any of this bloating that you typically get. So if you like have a big meal, let's say a big McDonald's, all these kind of vegetable oils is in this shit, and you're gonna bloat, and then you're basically gonna have a crash. You're gonna be all sleepy and all this kind of shit. You don't get that when you're on the carnivore diet. You basically you eat your meal. You have your satiety. You feel full because you're eating fat, which doesn't make you fat, because if you eat excess fat, your body just gets rid of it. It doesn't try to hold on to it. So you base your feeling.
Okay. I hate people who don't know anything about science. Yeah, the satiety thing is true. Yeah, because the fat will form globules around the nutrients, and it will have to get fermented or digested in your colon, I'm pretty sure, or rather your large intestine. But yeah, it's not that your body doesn't hold on to excess fats. It's that in order to digest fat, you need something called bile salts, and you will only produce a certain amount of bile salts per, like, yeah, there's a cap on how much that you can produce. So your body just won't absorb it anymore. So if you're eating excess fats, they just go out through your ass. So that's why if you talk to some of the carnivore people, you'll hear a lot of stories of explosive diarrhea because there's just fat shooting out of your ass constantly if you're consuming way too much fat. So something to watch out for. Let's put it down. Won't get fat from excess fat.
And full, and you don't get the crash or the sugar crash and all the shit that you feel from carbs and shit like that as well. And when we're talking about muscle building, as you kind of seen from some of the amino acids that I mentioned, they're very good at like repairing tissues, muscle growth hormone production, all this kind of stuff. This is why animal protein is essential for muscle building. And this is just not only just like for like the people who are like
amino acids essential for muscle growth. No shit. No shit. Yeah. Okay.
Like in the gym every single day. These are people like myself. I'm relatively sedentary life. I work out 30 minutes a week. Like on Sundays, I do a 30-minute session. That's it. But if I don't eat animal protein, it literally feels as though all my body, like my muscles are wrecked and all that kind of shit the following day. Whereas if I eat the almost 2 pounds of I eat about 2 pounds of animal protein a day.
Jesus. 2 pounds of animal protein a day. Okay, actually, you know what? We're gonna lower anecdote. Okay. 30 minutes of exercise a week. Muscles feel wrecked. Otherwise, yeah, it's because you're not actually building muscle. It's because you're you're a little bitch soy boy. Great, good for you. Holy shit, 4 minutes left. We're gonna make it.
Like I feel nothing the next day. Like I might feel a bit tired or whatever, but it's not like my muscles aren't like basically don't feel as though they're broken, all that kind of shit.
Yeah, okay. So don't feel sore because no carbs. Yeah, that's kind of true. Yeah, I think I mentioned earlier that insulin is a trigger for muscle growth and protein synthesis. After you work out, your muscles store glucose inside of them in a form called glycogen. After you work out and you deplete your glycogen reserves, that's why most people eat sugars and shit after their workout, because you can synthesize more glycogen. Your insulin will sequester that into your muscle cells, and then having glycogen there and insulin there will actually enhance your muscle growth. This is why there are bodybuilders out there who are, doing roids and also injecting insulin alongside of it, which is hilarious.
Issue. And finally, to just wrap up on this section, the protein quality and digestibility. So again, there's tons of studies out there that because of all these amino acids and all this stuff, the protein is able to digest like basically twice the rate as it is with the plant protein. And as well as this meat is not robbing you from all these, like its base doesn't have anti-nutrients. It's not robbing you from your minerals. It's not robbing you from your vitamins. It's actually putting minerals and vitamins into your body as well. So that's another thing about this vegan food.
Okay, whatever. So we already covered this in the soy section, which is fine. Not robbing your body of minerals and nutrients, actually putting them into your body. Yeah, well, depending on what kind of meat you're eating, obviously. It's not, if you're just eating muscle meat, you're not going to get your full spectrum of vitamins and minerals.
But a vegan diet where on paper or in theory you might be able to do it, but it's just you constantly have to be eating like different things and all different range, and your diet's completely complex and it's all this weird food and all this kind
of. Your diet is completely complex. Eating all this weird food. I don't know what kind of points these are. Like, these are all normatively loaded, really kind of dumb statements.
rather than just having a steak or having some ground beef, essentially.
Constantly.
Finally, just to wrap up on the cholesterol myth, the one or the only thing that they'll be able to distinguish.
Jesus, how much rapid fire bullshit can one person put out? Cholesterol myth.
It's like you'll see all these like carnivore videos online on YouTube, and they'll have their blood work done, and the only thing that they'll point to is say, "See, look at your cholesterol increase." That's the only marker that they can point to. Vegans point to and say it's like, "Yo, you're deficient in this," or like, "This is unhealthy." What they don't realize is because your total cholesterol will increase, but your
Hang on. Goddamn timed ass lights. Okay. So vegans can only point to higher cholesterol.
increasing the good cholesterol, the HDL, not the LDL. Deficient in this, or like, "This is unhealthy." What they don't realize is because your total cholesterol will increase, but you're increasing the good cholesterol, the HDL, not the LDL. And
only
you want to work out if your cholesterol is healthy, it's your total cholesterol divided by your HDL. And a ratio of 5-1 or lower is considered good.
5-1 ratio of, what's that, total divided by?
So again, if you want to work out if your cholesterol is healthy, it's your total cholesterol divided by your HDL. And a ratio of 5-1 or lower is considered good. So again, if we have, let's say, 100 LDL and, like fucking 400 HDL, and then that's 5-1 beforehand, but then we increase both of them by 200, then we go to 600 and 300, then we're down to 2-1. So it's actually healthier. It's a lower ratio. So it's like, anytime they bring up cholesterol or any of that shit, just kind of say to them, how would you work out a healthy cholesterol? And they'll say they don't know. Then why are they even bringing that up in the first place? Just because your cholesterol increases doesn't mean that it's a negative thing.
I don't necessarily know if that's true. Let's see. What 400 HDL to plus 200 of both. 300, 600, which is what, 1 to 2? Well, no, that'd be 2 to 3. Total would be 900 divided by your HDL. Yeah, which is 3 to 2. Okay, we can do math.
It's your ratio that you need to worry about. That's pretty much everything I have in terms of that. But like I said, like don't eat the seed oils, don't eat the soy, eat your meat. Red meat is best, preferably beef or bison. I think bison is a popular thing in America as well. You want to get like high fat cuts like ribeye or 20
Jesus. Conclusion. Fatty cuts of red meat is best. Let's see if he mentions anything about cooking it.
20% ground beef. You want to make sure that you're getting as much grams of protein as you're getting. You want to make sure you're getting as much grams of fat as well, and then you should be good to go. Another thing as well, I just want to kind of really quickly just finish off on is just like this, like I said, this unholy relationship that you find between the medical profession and the big food, big pharma and big food, if you want to call them that, is that like they're intentionally growing shit food.
Big food and big pharma are in cahoots to keep you sick for money.
Cheap food.
I don't need to explain why this is stupid, but I'm going to do it anyway. Yeah, this is obviously dumb. This is conspiratorial, anti-establishment, anti-big stuff garbage. But yeah, it's just dumb. This is the thought that weak people put out there, because they're afraid, because they don't know how the world works, because they're not very intelligent, and so they need to find an explanation because it's comforting.
Like basically kind of like not doing proper conditions at all, like trying to max out like their book per acre rather than actually having rotating the crops like we're speaking about earlier. Like they're basically just like using the whole farmland to grow constantly 24/7 rather than rotating for like basically dividing the
They're not rotating crops. Holy shit. Last 60 seconds.
whole crop into 4 and then rotating the crops around, letting the cows graze in one area and letting them fertilize it naturally and all that kind of shit, and then rotating it throughout the year. They're just trying to like grow all the space. They're trying to grow 24/7 all the shit, and like you see they have like fucked up species of corn, all that kind of shit now that's basically, like I said, it's just robbing you from nutrients, all the stuff.
Fucked up species of corn robbing you of nutrients. No, he's probably talking about GMOs, which is not why GMOs are a concern. Where the issue is they have spliced genes to make crops resistant to pesticides, so they can just drench it in pesticides, which is fine for the crops, won't actually do anything, but yeah, the issue is you have that stuff soaking in, and that stuff is not great to consume. Stupid.
And what do they tell you to do? Rather than tell you to actually go and research, like I just showed you there, do a bit of research, like all this stuff, like you can get it from Google, you can get it from AI, it's all there. You just have
Jesus fucking Christ. Okay. This guy got everything. He went to ChatGPT, typed in why meat good, why plants bad, and doesn't actually know what the fuck he's talking about. I'm glad he admitted it.
have to put in a little bit of effort to look it up. They don't want you doing that though. They want to just give you a pill so you can just continue.
God, I hate him. They don't want you to look up these studies on AI. They just want to give you a pill. That's not true. The problem is people. The problem isn't the medical professionals. People don't want a doctor to tell them like, hey, you need to not sit on the couch all the time. You need to go outside and exercise. You need to actively take care of yourself. You need to not eat out for every meal. People don't listen to that. It's not the medical professionals that just want to shove pills on you and let you leave. It's the people going there, because if you go to a doctor and they refuse to give you blood pressure medication or cholesterol medication, and they're like, no, you just need to exercise, you need to actually like put in the work and do it properly. People don't keep going to those doctors. They go to a different doctor and they go and get a pill, and it forces medical professionals' hands. And but yeah, whatever. Not the dumbest thing he said. Well, yeah, pretty close to it.
Continue this bad behavior or this fucked up food that they're basically giving you, and basically they want you to continue to poison yourself. So they're basically feeding you poison, and they're giving you this, what is essentially this medication, which is poison, to counteract the current poison that you're eating, just so you can.
They're feeding you poison. And you basically poison, then giving you actual poison to counteract the poison, so you can keep eating it. Great. Whatever. I just explained that.
Continue eating the poison. It's a very nasty circle, and we need to end it as soon as possible. We need to get back on the steaks, get back on the meat, and stop this soy boy trend. You know what I'm saying?
Okay. Holy shit. Can I never watch that again? Jesus fucking Christ. Okay. So now we have a list of stuff that we can start going through. Oh, cool, cool. Cool, cool, cool. We're actually, where even to start? God, fucking kill me. Take care of my fucking pokes. Okay, okay, okay. We have some studies already. Oh, let me open up my citation. Distraction is uh, okay. So I guess we can start reading about seed oils. Okay. All right. We're gonna get a little bit of music. Oh, no. Loud. That's too loud. We'll figure that out later. Fuck. Okay. All right. We're actually gonna start reading papers now. Sorry, I'm fucking goddamn draining. Okay, so this is a study that basically this is going to debunk that whole high quality fats thing. Rather, that meats have high quality fats and polyunsaturated fatty acids are the worst. This is a God, what's the word? Whatever. This is a study going through diets where they equalize the number of calories being taken in, but just swapped out saturated fats, which is which you normally find in animal products, with polyunsaturated fatty acids, which are found in seed oils, which are apparently evil. So yeah. Replacement of dietary saturated fat by PUFA-rich pumpkin seed oil attenuates non-alcoholic fatty liver disease and atherosclerosis development with additional health effects of virgin over refined oil. Background. As dietary saturated fatty acids are associated with metabolic and cardiovascular disease, a potentially interesting strategy to reduce disease risk is modification of the quality of fat consumed. Vegetable oils represent an attractive target for intervention, as they largely determine the intake of dietary fats. Furthermore, besides potential health effects conferred by the type of fatty acids in a vegetable oil, other minor components, e.g. phytochemicals, may also have health benefits. Here we investigated the potential long-term health effects of isocaloric substitution of dietary fat, i.e. partial replacement of saturated by unsaturated fats, as well as putative additional effects of phytochemicals present in unrefined virgin oil on development of non-alcoholic fatty liver disease and associated atherosclerosis. For this, we used pumpkin seed oil because it is high in unsaturated fatty acids and a rich source of phytochemicals. Methods: ApoE3 mice were fed a Western-type diet containing cocoa butter, 15% weight by weight, and cholesterol, 1% weight by weight, for 20 weeks to induce risk factors and disease endpoints. In separate groups, cocoa butter was replaced by refined or virgin pumpkin seed oil, comparable in fatty acid composition but different in phytochemical content. Both results. Both oils improved dyslipidemia with decreased VLDL and triglyceride levels in comparison with con, and additional cholesterol lowering effects of virgin over refined. While refined did not affect plasma inflammatory markers, virgin reduced circulating serum amyloid A and soluble vascular adhesion molecule 1. I actually don't know what that one is. Alright, we're rabbit holing immediately, I guess. Scam. So, soluble cell adhesion molecules are a class of cell adhesion molecule. Wow, thanks. CAMs are... Oh, okay. Cell surface binding proteins that may represent important biomarkers for inflammatory processes involving activation or damage to cells, such as platelets and the endothelium. They include soluble isoforms of the cell adhesion molecules ICAM1, VCAM1, E-selectin, and P-selectin. The cellular expression of CAMs is difficult to assess clinically, but these soluble forms are present in the circulation and may serve as markers for CAMs. Research is focused on their role in cardiovascular, connective tissue, and neoplastic diseases, where blood plasma levels may be a marker of the disease severity or prognosis, and they may be useful in evaluating progress of some treatments. Many studies have postulated that increased production of cell adhesion molecules on the vascular endothelium plays a role in the development of arterial plaque, with a suggestion from both in vitro and in vivo studies that the CAM production is increased by dyslipidemia, which is abnormal lipid levels in the blood. Research studies have used scans as biomarkers to measure correlation with nutrients or nutrient levels as significant or not. Okay, so they're a biomarker for inflammation. Cool. Non-alcoholic fatty liver disease and atherosclerosis development was modestly reduced and refined, and virgin strongly decreased liver steatosis, and inflammation, as well as atherosclerotic lesion area and severity. Overall, we show that an isopolaric switch from a diet rich in saturated fat to a diet rich in unsaturated fat can attenuate non-alcoholic fatty liver disease and atherosclerosis development. Phytochemical-rich virgin pumpkin seed oil exerts additional anti-inflammatory effects, resulting in more pronounced health effects. So cool. And so we're gonna throw this guy in here. I need to pick a better place to start. Okay. Oh, yeah. I actually read about this before. Like how we test for mutagenicity, or like how cancerous something is something called the Ames test. We're gonna read the wiki for it real quick. So the Ames test is a widely employed method that uses bacteria to test whether a given chemical can cause mutations in the DNA of the test organisms. More formally, it is a biological assay to assess the mutagenic potential of chemical compounds. A positive test indicates that the chemical is mutagenic and therefore may act as a carcinogen, because cancer is often linked to mutation. The test serves as a quick and convenient assay to estimate the carcinogenic potential of a compound, because standard carcinogen assays on mice and rats are time-consuming, taking 2 to 3 years to complete, and expensive. However, false positives and false negatives are known. But yeah, kind of neat. It's a test from the 70s. Uses a type of salmonella, and they have a gene, or use a form of salmonella that requires a certain amino acid, histidine, that we brought up earlier. And yeah, basically they grow the bacteria, and it has this gene that can make the histidine, and they eventually knock that gene out. So they mutate that gene in some sort of way, and then they add the compound that they're testing to see if it will change, or to see whether or not it will mutate the DNA and be able to produce its own histidine and be able to survive. So, yeah, picture's great. Which, yeah, kind of illustrates what's going on there, where they grow it in a petri dish with histidine in it until it's all been consumed, and then with the compound in there, they can check if there's a lot of colonies of bacteria that have grown, and they can tell that there's a pretty high level of mutation present in the compound, or if not, they won't see any bacteria grow. which is kind of cool. God, I should reorganize this. Fuck. Okay. Why do we do this? Let's see. What is the dietitian? Oh God, what was it called? Let's kind of go through this as well. I think this is a little older. Yeah, this is a couple years old, but this covers a lot of the soy stuff. The anti-nutrient stuff, which is kind of a hacky bullshit, tricky thing that he brought up without anyway. So, is a concern about these compounds found in many plant foods, much ado about nothing. The question of whether people should avoid foods that contain anti-nutrients is a hot topic, with many vigorous opinions available via a quick internet search. While several healthful foods have been thrown under the bus by those in the avoid anti-nutrients camp, soy, a staple food in healthful traditional Asian diets, often takes an extra hit because it contains so many different types of anti-nutrients. Anti-nutrients are naturally occurring compounds found in many plant-based foods. Think pulses, which are beans, peas, and lentils, whole grains, nuts, seeds, and many vegetables. Many bloggers, book authors, and other experts claim that people should avoid foods that contain anti-nutrients for a few reasons, including the fact that they can theoretically bind to certain nutrients, reducing the body's ability to digest and absorb them. While it's true that anti-nutrients can have negative health effects, they can also have positive effects. Is it enough to look only at what anti-nutrients may do in a lab in animal studies, or should the focus be on whether anti-nutrients are a problem in foods they're typically prepared and eaten by humans? Today's dietitian takes a closer look. Phytate. Soybeans contain high concentrations of phytate, also known as phytic acid, one of the most common types of anti-nutrients, found in seeds, nuts, legumes, and grains. Phytate can bind strongly to iron and zinc, and calcium, magnesium, and potassium to a lesser degree, forming insoluble complexes that can't be absorbed by the intestine. So, kind of true, making them less bioavailable. Phytate also reduces the bioavailability of vitamins A, B12, D, and E. However, phytate has antioxidant and anti-inflammatory properties, and research suggests it may help prevent cardiovascular disease and some forms of cancer, including colon, liver, lung, breast, skin, and prostate cancers. In vitro and in vivo studies have shown that phytic acid reduces proliferation of cancer cells and may contribute to cancer cells reverting to normal cells. Since phytate primarily is found in high-fiber foods, this may be one reason why high-fiber diets are associated with lower cancer risk. Moreover, phytate has been observed to reduce starch digestion, lower the glycemic index of foods, and generally have positive effects on blood glucose levels. Hi, hello, Mr. Man. Hello, Mr. Man. Hello. You want to say hi? Say meow. Jesus. Has also shown positive effects on blood cholesterol in rodent studies, possibly due to increased excretion of bile acids and lipids in the feces. Another proposed cholesterol-lowering mechanism of phytate is that it inhibits the liver enzymes involved in lipogenesis, the production of triglycerides and fatty acids from glucose. Phytate may also prevent kidney stone development by inhibiting formation of calcium salt crystals. In food preparation, fermentation, and sprouting reduces. Oh, in food preparation, fermentation, and sprouting reduces phytate levels, but cooking at temperatures used in home kitchens doesn't. Some foods are processed with phytases, enzymes found in plants, fungi, animals, and to a lesser extent humans that can break down phytate to reduce phytate in the final product. Humans also degrade 37% to 66% of phytate during digestion in the stomach and small intestine when the diet is rich in plant phytases, but phytases generally are inactivated by cooking and food preparation. The Western style diet is low in phytases as plant intake is low and those plants are often cooked, so people eating this style of diet will have low rates of phytate degradation during digestion. If clients are eating both cooked and raw plant foods, this should be less of an issue. Ironically, that relative lack of breakdown may be a good thing. Phytate's health benefits are more significant for people living in the United States and other developed countries, where rates of cancer, especially colon cancer, are higher because of the higher fat and lower fiber intakes. In other words, because of a Western-style diet. These populations generally don't suffer from mineral deficiencies because they're eating a varied and balanced diet. In low-income countries, poor mineral absorption from high phytate diets is a major factor in iron and zinc deficiency. The bottom line is that there's no evidence that eating moderate amounts of soy causes deficiencies. So, where is phytate? Okay. What do you want to write down here? Phytates have whatever. Listen, we'll organize notes later. And lectin. Soy contains moderate concentrations of lectins, a group of proteins known as glycoprotein found in most plants, especially beans and whole grains. Lectins can interfere with the absorption of minerals, especially calcium, iron, phosphorus, and zinc. Much also has been made of the idea that lectins are a threat to gut health, in part because they can bind to epithelial cells lining the intestine, potentially altering gut permeability and passing through the gut into the bloodstream. But the only evidence supporting that claim comes from studies that involved feeding either isolated lectins or raw beans to animals. We are actually going to write that down. Only evidence supporting this claim comes from studies that involve feeding either isolated lectins or raw beans to animals. Considering some of the outsized negative claims about lectins, there's not much research on their effects on human health. What's clear is that lectins are almost entirely destroyed by heat, with moist heat being the most effective. For example, there's evidence that cookies made with soy flour still retain some lectin activity, although not at a level thought to pose a health risk. Boiling beans for 15 minutes, simmering for 2 hours, or pressure cooking for 45 minutes has been demonstrated to lower lectin activity below detectable levels. It's also worth noting, especially to clients, that the benefits of a plant-based diet, which naturally contains many sources of lectins, is well established. Not much human research. Most cooking methods reduce lectin activity below detectable levels. Distinguish between his stuff and my stuff somehow. Alright. Protease inhibitors. Soy and other legumes contain high levels of protease inhibitors that protect the growing plants against insect damage, but also bind to the digestive enzymes chymotrypsin and trypsin in animals and humans. This can interfere with the digestion of protein and trigger the pancreas to produce excessive amounts of digestive enzymes, leading to an enlarged pancreas in animal research, much of which use raw legumes or isolated protease inhibitors. Research is scant on human subjects. In one human study, direct infusion of purified Bowman-Burke inhibitor, one common type of protease inhibitor, significantly increased production of trypsin and chymotrypsin in the pancreas, but in real life, humans don't consume isolated enzyme inhibitors, while Kunitz-type inhibitors in soy appear to be completely inactivated by human gastric juice, while BBI remains active. It's important to note that humans also rarely eat soy or other legumes without previous heat treatment, and cooking and soaking, to a lesser extent, reduces levels of these enzyme inhibitors. Unlike with lectins, dry heat, such as roasting and toasting, appears to be more effective than moist heat in deactivating protease inhibitors. In recent years, new techniques have been developed to reduce protease inhibitor concentration and activity in soy milk. Not much human research. Dry heat tends to in one human study, direct infusion of purified Bowman Burke inhibitor significantly increased production of trypsin and trypsin. God, spelling is hard. In the pancreas. However, in real life, humans don't consume isolated enzyme inhibitors. Units type in in soy seem to be completely inactivated by human gastric juice, while BBI remains active. And yank that source. Okay. Go through and read this later. Important to note that humans dry heat seems to be effective in deactivating protease inhibitors. And that is 5. You research gate, whatever. Welcome. No. What? Welcome. BBI has anti-inflammatory, antimicrobial, and immune modulating properties, and purified BBI has been used as a cancer preventative agent because of its ability to block proliferation of cancer cells. Soybean BBI has been shown to have the ability to suppress expression of various oncogenes, genes that have the potential to cause cancer. It's also been used to help treat inflammatory bowel disease and other inflammatory and autoimmune diseases. Soy BBI also has been used to prevent replication of HIV. Units type inhibitor from soy also may help prevent cancer cell invasion and metastasis. Good. Oh, phytates. Reduce the current of kidney sense. Mark, right? Is it? Fuck, you spell occurrence. Damn it. Alright. Let's see what I got there, okay. Oxalates. Oxalates are present in clinically meaningful amounts in about 75% of all flowering plants, including soy. A 2005 study found a wide range of oxalate levels in soy foods from 2 to 58 milligrams per serving. According to criteria established by researchers, soy foods that have undergone more processing, such as tofu, soy milk, and soy sauce, tend to be low oxalate, while more minimally processed soy foods, such as soy flour, textured vegetable protein, soy nuts, edamame, and soy nut butter, are inclined to be high oxalate. Oxalates are a major component in kidney stone formation, and foods containing more than 10 milligrams of oxalate per serving are considered high oxalate foods. However, while frequently consuming much soy or other higher oxalate foods can lead to the formation of kidney stones in susceptible people, simply reducing dietary oxalates isn't a healthful prevention strategy. Oxalates also bind to calcium and other minerals in the small intestine, reducing absorption and potentially leading to deficiencies. Taylor Wolfram, MSRDN LDN, a Chicago-based vegan dietitian, says she isn't concerned about oxalates in soy. She simply makes sure her vegan clients know that oxalates significantly reduce calcium absorption from greens, so they shouldn't rely on spinach and Swiss chard for calcium, even though those greens do have a high calcium content. Instead, she suggests they include a wide array of leafy greens and cruciferous vegetables in their diets. Major component of kidney stone formation. Corn mix is high oxalate food. Okay. All right, I guess the oxalates part wasn't that bad. Saponins, whatever the fuck. Soy and other legumes are rich in saponins, a class of bioactive compounds found in many plant species that protects plants against pathogens, pests, and foraging animals due to antimicrobial, antifungal, antiparasitic, insecticidal, and anti-fedant properties. What the fuck is anti-fedant properties? Anti-fedant. Anti-fedant. Repel herbivores through distaste or toxicity. Instead, confer longevity. What is the difference between anti-fedant? Oh. Okay. Whatever. Word for insecticide. In general, saponins have many properties that can have positive or negative effects in humans and various animals. Popular claims on the internet state that these saponins can block nutrient absorption, damage cholesterol, disrupt endocrine function, kill cells, and increase intestinal permeability. All saponins have been shown to increase intestinal permeability in vitro and in animal research, which could theoretically contribute to autoimmune disease. Most effects touted as negative can be considered positive. In fact, saponins in animals and in vitro studies also have shown that saponins have antioxidant, immune modulating, anti-carcinogenic, anti-inflammatory, and antimicrobial properties. Notably, saponin. How the fuck do you spell saponin? Or say saponins? Saponin. Okay, it is. I was right, damn it. Notably, saponins have cardiovascular benefits due to their cholesterol-lowering effects through a variety of mechanisms. Many saponins form insoluble complexes with cholesterol in the gut, suppressing intestinal reabsorption of cholesterol. They're similarly able to reduce reabsorption of bile acids. This has been demonstrated in rodent models. Animal research also has demonstrated that soy saponins have antithrombotic effect by reducing blood platelets and fibrinogen levels. Furthermore, saponins have been shown to modulate expression of genes related to the enzymes and transporters involved in carbohydrate metabolism, which can help normalize blood glucose and insulin levels. They're capable of improving insulin resistance through alteration of other mechanisms involved in carbohydrate metabolism, and saponins may play a role in soy's protective effects against cancer. In vitro studies have found that soy saponins suppress cancer cell growth and inhibit survival, especially colon cancer cells. In lab research, saponins have been shown to downregulate genes related to the formation of fat cells from stem cells at adipogenesis, reduce production of pancreatic lipase, and inhibit intestinal fat absorption. This could have benefits for body composition. While saponins can interfere with nutrient absorption as well as with other anti-nutrients, the degree of interference will depend on the individual person's metabolism, what other foods are in the meal, and how the anti-nutrient containing food is prepared. Studies of the effects of various cooking and food processing methods on saponin levels have produced inconsistent results, with some showing a significant decrease and others almost no decrease. Bottom line for RDs. Soy and other foods containing anti-nutrients are considered traditional foods that are staples in the diets of some of the healthiest populations around the world. The demonization of specific foods or food components because they theoretically could cause problems, even if highly unlikely based on how we eat them, or because they do cause problems for a small percentage of people, is a troubling trend. Given all the information and misinformation online about anti-nutrients, how should dietitians approach the topic with clients who ask about it or believe they should avoid certain foods because they contain anti-nutrients? Other than oxalates, Wolfram says she doesn't express much caution around anti-nutrients. However, if a client specifically asks, she says she tends to say something short and sweet, such as there are some naturally occurring compounds in plants that might interfere with the absorption of some nutrients, but that effect is usually small and insignificant, and in many cases, cooking often neutralizes it. The nutritional benefits of eating in abundance, variety, and balance of plant food far outweigh any concerns about anti-nutrients. By balance, Wolfram says she means making the client is getting enough legumes, grains, nuts, and seeds in addition to fruits and veggies. Then, if someone wants to know more or asks about a specific anti-nutrient, she'll give more specific information. Regarding the effects of cooking, fermenting, and processing on degrading anti-nutrients, Wolfram says she doesn't advise people to worry about this. Soy is just one component of many in a varied, balanced eating pattern, even for plant-based eaters who eat more soy than meat eaters, she says, and many other plant foods deliver the nutrients of concern here. Much of the confusion about anti-nutrients may come from simply not seeing the forest for the trees. In other words, some individuals only focus on the fact that yes, some foods have anti-nutrients and that anti-nutrients could have some unwanted effects. They don't consider the ways in which people prepare and consume those foods may help degrade the anti-nutrients, or the fact that anti-nutrients and the foods containing them also have health benefits. Unfortunately, this narrow view and understanding of nutrition is so rampant in wellness conversations by folks who aren't RDs and those who don't know how to critically evaluate research, Wolfram says. Hey, it's our boy. We have to spend a lot of our time as RDs explaining why folks don't need to worry so much. She says dietitians can sound boring when reminding people to eat enough of all the food groups, take any necessary dietary supplements, and practice intuitive eating. But for the generally healthy adult, that's what good nutrition is about. I see anti-nutrients as a trendy topic, and that wellness folks use to stay relevant and garner fear and attention that keeps their audiences attentive. Oxalates and phytates aren't new, they're just a little tidbit the wellness community has picked up and decided to co-opt, especially those pushing a meat-heavy or meat-only diet. Kind of reminds me of food trends. Never saw cauliflower becoming trendy. What will it be next? What a great article. It's like they're speaking directly to me. Soy and anti-nutrients. Great. That covers what, almost every fucking thing you put in here. Cool. All right, we're gonna go for like 2 more, I think, and then I'm gonna go crash. I've been sleeping that much lately. Let's go phytoestrogen. Phytoestrogen's effects on males. You know, I have one of these. But information. Oh no. Why all this stuff is old as fuck? on that. Oh, perfect. Okay. Neither soy nor isoflavone intake affects male reproductive hormones. An expanded and updated meta-analysis of clinical studies. Remember, meta-analyses are good. They're the best. They're combining a lot of trials at once. Sorry, I'm looking at. Sorry, distraction. Okay. So, concerned that the phytoestrogens in soy may feminize men continue to be raised. Several studies and case reports describing feminizing effects, including lowering testosterone levels and raising estrogen levels in men, have been published. For this reason, the clinical data were meta-analyzed to determine whether soy or isoflavone intake affects total testosterone, free testosterone, estradiol, estrone, and sex hormone binding globulin. PubMed and cab extracts. Sorry, before I lose it. Databases were searched between 2010 and 2020 with use of controlled vocabulary specific to the databases. Peer-reviewed studies published in English were selected if 1. Adult men consume soy food, soy protein, or isoflavone extracts from soy or red clover, and 2. Circulating total testosterone, free testosterone, sex hormone binding globulin, estradiol, or estrone was assessed. Data were extracted by 2 independent reviewers. With one exception, the studies included in a 2010 meta-analysis were included in the current analysis. A total of 41 studies were included in the analyses. TT and FT levels were measured in 1,753 and 752 men, respectively. E2 and E1 levels were measured in 1,239 men, respectively, and SHBG was measured in 967 men. Regardless of the statistical model, no significant effects of soy protein or isoflavone intake on any of the outcomes measured were found. Sub-analysis of the data according to isoflavone dose and study duration also showed no effect. This updated and expanded meta-analysis indicates that regardless of dose, study duration, neither soy protein nor isoflavone exposure affects TT, FT, E2, or E1 levels in men. Okay, you know what? We're gonna read the whole fucking introduction because fuck it. For centuries, foods made from soybeans, such as tofu and miso, have played an important role in the diets of many Asian countries. Much more recently, soy foods have become popular in many non-Asian countries because of their purported nutritional and health benefits and the increased interest in plant-based diets and plant protein. In addition to the traditional Asian soy foods, soy protein can be incorporated into the diet via supplementation with and/or by consuming foods containing soy protein ingredients, namely soy flour, soy protein concentrate, and soy protein isolate. On a moisture-free basis, these products are approximately 50, 65, and 90% protein, respectively. Much of the soy-related health research published over the past 3 decades has taken place because among commonly consumed foods, the soybean is a uniquely rich source of isoflavones. Mean isoflavone intake in Japan among older adults ranges from approximately 30 to 50 milligrams per day, whereas per capita isoflavone intake in the United States and Europe is less than 3 milligrams per day. The 3 isoflavones, genistein, didzin, and glycine, and their respective glycosides comprise approximately 40, 50, and 10% of the total soybean isoflavones content, respectively. Each gram of soy protein in traditional soy foods is associated with approximately 3.5 milligrams isoflavones, expressed as aglycone equivalent weight. The fuck is aglycone? Rabbit holes. Which a sugar group glycone is bonded to a non-sugar aglycone through its anomeric carbon to another group via an O-glycidic bond or an S-glycidic bond. Bioglycosides. Okay. In contrast, much of the isoflavone content is lost in the production of SPI and SPC, although the degree of loss depends upon the method of manufacture. Isoflavone values in this manuscript refer to aglycone equivalent weight. Isoflavones have a chemical structure similar to the hormone estrogen, which allows them to bind to both estrogen receptors, ER alpha and ER beta, and to exert estrogen-like effects under certain experimental conditions. For this reason, they are commonly classified as phytoestrogens. Circulating levels of isoflavones in response to the ingestion of approximately 2 servings of traditional soy foods are 3 orders of magnitude higher than estrogen. However, isoflavones differ from estrogen at the molecular level in that they preferentially bind to and activate ER beta in comparison to ER alpha, whereas estrogen has equal affinity for both receptors. This difference in binding preference is important because the 2 estrogen receptors have different tissue distributions and, when activated, can exert different and sometimes opposite physiological effects. The preference of isoflavones for ER beta is the primary reason that isoflavones are seen as capable of having tissue selective effects, and the reason they are often classified as selective estrogen receptor modulators. Isoflavones have been rigorously investigated over the past 30 years for a number of potential health benefits in both men and women. However, isoflavones are not without controversy, as there is concern that isoflavones feminize men. This concern, which coincided with the rising apprehension that environmental estrogens play a role in the declining sperm count occurring among men worldwide, has some support from animal studies. Some clinical studies have also reported decreases in testosterone levels in response to soy consumption. In addition, one case report described a 6-year-old male who developed gynecomastia allegedly as a result of his soy intake, and a small case control study found that soy intake was associated with lower sperm concentration among male partners in subfertile couples who presented for semen analysis to the Massachusetts General Hospital Fertility Center. As a result of feminization concerns, in 2010, 3 of us co-authored a meta-analysis of clinical studies that examined the effects of isoflavone exposure via supplements and soy foods on circulating levels of total TT, FT, and SHBG. This analysis found no statistically significant effects of soy protein or isoflavone intake on any of the outcomes assessed. That same year also saw the publication of a narrative review which found soy/isoflavones had no effect on estrogen levels in men or other endpoints related to feminization. Nevertheless, results of soy exerting estrogenic or feminizing effects subsequent to the 2010 meta-analysis and narrative review have been published. For example, a case report by Seatman et al. Described a 19-year-old vegan who developed hypogonadism and erectile dysfunction allegedly as a result of his soy consumption. It is notable that the man described in this case report and in the previously cited one consumed an estimated 360 milligrams per day isoflavones, which is approximately 9 times the typical intake of older native Japanese men. Also, in young resistance-trained men, supplementation with soy protein resulted in lower testosterone levels shortly after exercise performance in comparison to whey protein carbohydrate supplementation. Observational studies have also reported associations between isoflavone exposure and decreased sperm concentration and/or poor semen quality. Given the conflicting reports and the number of relevant studies published within the past decade, we have updated and expanded the 2010 meta-analysis. In addition to including levels of SHBG, TT, and FT, levels of E2 and E1 were also meta-analyzed since no previous statistical analysis of the effect of soy on these latter two hormones has been published. Alright, we're going to skip the fucking materials and methods because this is fucking boring. Based on the established criteria, a total of 41 studies were included in the analysis. Of the 41 studies, 20 utilized a parallel design, controlled 8 a crossover design, and 15 single arm or parallel arms designs. 2 studies identified by the literature search were excluded from the analysis because of their short duration, as one measured TT and SHBG over a 60-minute period following a bout of resistance exercise, and one measured ET, TT, and FT after 1 week exposure. In the latter study, which did not find a significant effect on hormone levels, it was not possible to determine the soy protein or isoflavone dose based on the description of the intervention product, 900 grams of soybeans. Jesus. In addition, a study by Lephart was excluded from analysis because the intervention supplement was comprised of Equal, which is a bacterial-derived metabolite of daidzein that is not found in soybeans. Also, a study by Granger et al. Was not included in the current analysis, despite being included in the 2010 meta-analysis, because the original data, which was not published in the paper, is no longer accessible. Some studies included soy groups that were excluded from the analysis due to the addition of other potentially bioactive ingredients to the test product. This included soy bread with linseed, soy milk fortified with stanols, and a mixture of soy and whey. Selected details of the studies included in the meta-analysis are shown in Table 1. Running through the doses. I guess this is interesting in a lot of these are specifically for prostate cancer. Pretty good amount of healthy ones. Yeah. A lot of smaller studies. And times. TC and FT levels were measured in 1,753 and 752 men respectively. E2 and E1 levels, blah blah blah. We read this already. The youngest men were aged 18 years, and the oldest participants were aged 81 years. Several studies included more than one experimental arm. For example, a SPC arm and a SPI arm. Thus, the total number of groups included in analysis exceeded the total number of studies. Some studies involved multiple quantities of soy or soy in different forms. For example, both Swart et al. And Hamilton-Reeves et al. Included a SPI with added isoflavones group and a SPI alone group. Kalman et al. Included an SPI group and SPC group, and the study by Kumar et al. Included 3 groups who consumed supplements providing different amounts of isoflavones. Most studies that did not intervene with supplements used SPI or SPC. Several studies used other forms including red clover, soy milk or yogurt, tofu, or soybeans. effect of soy and isoflavone exposure on circulating reproductive hormone concentrations. Shown in Table 2, there were no significant effects of soy or isoflavone exposure on any of the hormones considered, regardless of whether the data were analyzed using statistical approach. A, comparison of change in the treatment versus the control arms of parallel or controlled and crossover trials, or B, change over time in all active arms. That's a pretty low p-value. Sub-analysis revealed that neither study duration, less than or equal to 12 weeks versus over 12 weeks, nor dose, less than 75 milligrams a day versus greater than or equal to 75 milligrams a day, affected the impact of isoflavone exposure on hormone concentrations. Although in the case of statistical model A, change in treatment arm compared with change in control arm, in several cases there were insufficient studies to conduct an analysis. Publication bias and over-influential studies. No publication bias was noted in the funnel plots. There were no over-influential studies in either analysis method for TTFT or SHBG. When studies were removed one at a time and the models then re-estimated. In analysis A, change in treatment versus change in control for E2, removal of the 2010 study by Kumar et al. Had the largest influence, although the model still remained non-significant. In the study by Han et al., the control group experienced a drop in E2 that was more than double the drop in the intervention arm. But removal of the study had little to no influence on the effect size. In fact, In fact, in the 13 studies that measured E2, there was a drop in the control group in all but 2 studies. However, as can be seen from analysis B, there is little actual change over time in the active arms. In the E1 analysis, removal of the study by Nagata et al. From analysis B had the largest influence, resulting in a relatively large change in the standard mean deviation, as it changed from 0.4 to 0.62, while the effect remained non-significant. P equals 0.06. It's basically with those p-values. We're looking for a p-value of under 0.05. That is, they're using a 95% confidence interval. It's basically the idea that, there's a 95% certainty that whatever, listen. Not exactly what that means, but whatever. You need a p-value of under 0.05 in order for something to be statistically significant. They can generate these numbers, but in reality, they can't for certain say that the average of both groups are meaningfully different unless that number gets low. It's just a form of statistical testing. Given the small number of groups in this analysis, removal of single studies can have a large influence. As was the case for E2, there is little actual change over time in the active arms. Okay. Well. Alright. I'm tighter than I thought. We'll probably pick this up tomorrow. Or we might switch to something else. I don't know. Maybe we'll go argue on panels with somebody. Find some cringe right-wingers to yell at. But yeah. I'm gonna go not play video games. That's for damn sure. God, you're just so wrong. So wrong. I don't understand why he feels so fucking confident. I don't know, whatever. He's obviously just ripping sources from other people. Just fine. There's nothing necessarily wrong with that. I mean, we read that the dietitian article, but yeah, I don't know. Obviously spent exactly 0 seconds trying to figure out if he was wrong. So but anyway, as I said, we'll pick this back up tomorrow. Or maybe I'll want to read about some other stuff. Maybe we'll argue with people. But anyway, stay gay, sleep well.